Hey everybody, welcome to Guided Problems for Chapter 8. I'm just going to jump right into them. So the first one is the average selling price of a smartphone purchased by a random sample of 32 customers was $323. Assume the population standard deviation was $31. Construct a confidence interval to estimate the average selling price in the population and calculate the margin of error. So I'm like, as usual with these, what I do is I just start with what I know. So the sample size, or N, is 32. And let's see, the average selling price, so I'm gonna call that X bar, that's the mean of the sample, is 323. The population standard deviation was 31. And then it's a 90% confidence interval, so 1 minus that confidence interval is gonna give us our alpha of 0.1. Or 0.9, or 1 minus 0.9. I think that's everything I know. So I'm going to show you how to use a function that will calculate the margin of error directly. It's called confidence.norm. And all you put in there are the alpha, standard deviation, and the size, which is n. Now, for this one, I know it's normal because I know the population standard deviation. If I don't know the population standard deviation, and instead I know the sample standard deviation, then I would use confidence.t for the student's t distribution. So there's my margin of error. And then my lower confidence limit and upper confidence limit are just the mean, or x bar, minus the margin of error. And my upper confidence limit is going to be the mean, or x bar, plus the margin of error. Wow, that's quite a big, oh, I did something wrong there. The margin of error right there. There we go. That makes more sense. Round to the nearest cent. So I always let Excel do the rounding for me. So the lower limit is 313.99, and the upper limit is 332.01. Then it wants the margin of error, which we calculated right here. So $9.01. That's it. So there is a formula, and if you want to try the formula, maybe it'll help you understand the interrelationship of things better, you can. But the confidence.norm function works really well. So on the next question, it's really similar, but now it's a random sample of 24 college men's basketball games, had an average attendance of 5192, sample standard deviation of 1763. So the only difference is that we have the sample standard deviation rather than the population standard deviation. So I'll start with what I know. Sample sizes, or N, is 24. The average attendance, or X bar, for the mean of the sample is 5192. The sample standard deviation, sometimes it's just shown as S, right? That's sample standard deviation, 1763. And then my alpha, which is 1 minus the confidence level, so 1 minus 0.99 is going to be 0.01. So again, I can use the margin, I can find the margin of error directly, but this time, because I don't have a population standard deviation, I have to use the sample standard deviation, which means instead of using norm, confidence.norm, I'm going to use confidence.t. Same arguments though, it's the alpha, the sample standard deviation, and n, the size. There's my margin of error. And my lower confidence limit is just going to be x bar minus the margin of error. My upper confidence limit will be x bar plus the margin of error. Ask this to round to whole numbers, so I'll let Excel do that for me. 4182 and 6202. So based on past experience, we are 99% confident that at our next game, we'll have an attendance somewhere between 4182 and 6202, unless of course there's some sort of like confounding variable, right? Like we're playing our rival, so we're going to have way more people there, or we're playing on a holiday, so a lot of people are out of town, right? So that's just based on past experience. All right, so it says what assumptions need to be made about the population. And the only assumption I know that we have to make about the population is that the population is normally distributed, or that it follows a normal distribution. There we go. All right, problem number 3. So this one involves a proportion. So unfortunately, unlike the other two where we're able to just use confidence.norm or confidence.t, with a proportion, we can't do that. With a proportion, we have to actually use a formula. So that's a little bit of a hassle. So let's start with what we know. So we have this claim, or this past measurement, I just call it a claim, that in 2017, 84 or 0.84 of individual tax returns are filed electronically. But now we have this year a sample size of 213, so n is 213. From this sample, 176 were filed electronically, so I'm going to call that x as 176. So our p bar, or our sample proportion, is just going to be x divided by n. So the claim from the past was 84%, and now we're observing 82.6%. Okay. My alpha is going to be 1 minus my confidence level, so 0.1. And that's what I know. So in order to figure the answer out, I need to figure out the standard error of the proportion. So you can look in your book for that formula. A lot of times I just go to question help and go to view an example. And if we skip and get into it a little bit, we'll see that our standard error of the proportion formula is right here. So what I like to do, which you don't have to do, but what I like to do is use the snipping tool and just take that formula right there, copy it, paste it. So now I have it over here in my Excel worksheet to make it easy to work on. And then I'm also going to take a picture or a snip of the formula for my confidence limits. Paste them in here. So I'll have them both right here to work from. You can just look in the book, you can write it down in your notes, and then you'll have it however it works best for you. So this is the approximate standard error of the proportion. This is the standard error of the proportion when we don't know all of the population data, okay? What you'll find is that the formula is the same whether it's the approximate one or if it's the actual standard of the proportion where we do know the population data. So this is, to find this, you do the square root of p bar times 1 minus p bar. So p bar, whoops, I didn't start with an equal sign, sorry. The square root of p bar times 1 minus p bar. There's the numerator divided by n. So there's our standard error of the proportion. And then we're going to need our critical z. The critical z-score is just the z-score of alpha divided by 2. So to find that, I take the absolute value of norm.s.inv of the alpha divided by 2. That's my critical z-score. So my margin of error then is just going to be my standard error of the proportion times my critical z. And now I can find my lower confidence limit, which is going to be p bar minus my margin of error, my upper confidence limit, which is P bar, plus the margin of error. This wants 3 decimal places. There we go. Margin of error is right here, 3 decimal places. .043. So again, this means we are 90% confident that the actual number, or actual, what's the word? The actual proportion of tax filers filing electronically is going to be somewhere between 78.4% and 86.9, or 0.74 and 0.869. So the last one's going to ask us if there's any evidence that the proportion has changed based on what we saw here. And so we would look back at the claim of 0.84 and say, does that fall within our confidence limits? And it does, right? And so if what we think it was in the past, or the claim in the past, and now what our sample says now, in essence, what we're saying is those two are really close together. And so we're going to say the sample does not provide evidence the proportion has changed, because the confidence interval includes the proportion from 2017. All right, here's our last one. So this one is construct a 99% confidence interval to estimate the population mean using the data below. So start with what we have. We have X bar. Whoops, I put A bar. X bar of 22. Remember, that's X bar means our sample mean. S, which is our sample standard deviation of 3.5. N, which is our sample size of 24. Big N, which is our population size of 180. So a couple things that we have to notice up front here so we can do this correctly. First, we have to recognize that we have S, a sample standard deviation, rather than the population standard deviation. So we can't use confidence.norm, what we would do if we knew the population standard deviation. Instead, to find the margin of error, we have to use confidence.t to find the standard deviation, or the margin of error. So, oh, I forgot to write down another thing I knew already, because I don't have my alpha on there. So our alpha, which is 1 minus the confidence level, or 0.01. All right, now I can do confidence.t, choose my alpha, my standard deviation, and my size, which is little n, sample size. All right, so the other thing I have to recognize is that my sample size is relatively close to my population size. And we learned before, or hopefully you've learned before, that if your sample size is greater than 5% of your population size, then you have to use something called a finite population correction factor. If you want to test to see how big your sample size is relative to your population size, you would just take the sample size divided by the population. You'll see I have 0.133. So my sample is 13% of my population. That's greater than 0.05. So I'm going to need to do this finite population correction factor. The finite population correction factor is the square root of big N minus little n, so the population minus the sample, divided by big N minus 1. That's always the formula for the finite population correction factor. And so then our corrected margin of error is going to be the margin of error times the finite population correction factor. And so now all we need to do our confidence interval is to take our X bar minus the corrected margin of error and X bar plus the corrected margin of error. They want the answer in 2 decimal places, so I'll let Excel do the rounding. And I'll say I am 99% confident that given these parameters, our population mean is somewhere between 20.13 and 23.87. That's it. So hopefully that wasn't too painful, and hopefully it gives you the tools you need to be successful on the rest of the assignment.